Hello, folks. This is Carl Freund again with Cambrian-AI Research, and I have a topic today that's about Qualcomm. Qualcomm is announcing a restructuring of its software portfolio for AI. And to help you understand what that's about, I've got Vinesh Sukumar here. He is the lead for AI products at Qualcomm Technologies. Thanks for joining us, Vinesh.
Thanks, Carl, for having me on your show.
My pleasure, my pleasure. So why don't we start just a high level. What kind of problems are you trying to solve here by repackaging, reintegrating, and extending your AI software stack?
Yeah, great question, Carl. I think one of the biggest things that we're trying to really solve through this announcements that we have through Qualcomm is the software unification across all of Qualcomm AI products. Our expectation is once you develop an application on any given form factor, any given vertical, it is easy to deploy on any other form factor vertical. Our expectation is by reducing the deployment time, we can drive scale and we can deploy any given use case across multiple segments.
Yeah, it's especially important as you branch out into new segments like data center, right?
That is correct.
You certainly don't want the developers to go off and have to use a whole different AI stack when you've got so many years of work already into developing this and supporting the AI stack you have today. So can you briefly describe what the structure looks like? And I know it's kind of hard to do with your hands, but if you could describe it. We've also got a paper on our website that has nice graphics on it.
Yeah, sure. It basically comes down to four important buckets, I would say, starting off with the most important element, which is the frameworks and runtime. From a framework and a runtime perspective, we at Qualcomm are basically looking at both performance and scalability. So we try to look at popular frameworks that the developer and ecosystem folks actually use, like TensorFlow, PyTorch, Onyx. We broadly support them. And at the same time, from an inferencing runtime perspective, we look at Onyx runtime, TensorFlow, Micro, DirectML, TF-Lite, Delegate, all those elements specifically to support scale, both in the Android and in the Windows space. And if you're looking at performance, we have what we call as Qualcomm Neural Processing SDK that really pushes the best of performance, best of efficiency, and gets out the maximum performance that you could get because it kind of bakes in the intrinsics in the hardware. The second portion of it, I would say, is mostly focusing on the developer libraries and services. This is where I think the meat of the software stack is available. It gets packaged under what we call as Qualcomm AI Engine Direct. You have elements like math libraries to accelerate computations. You have compilers to really make sure you can do a lot of scheduling of operations and all the complex functions associated with with AI engines. You look at possibly virtual platforms, profilers, and code libraries, especially when you want to look at graphical representations, or you want to debug when a code is not functional, or you want to optimize a certain flow, especially with, when latency is involved. You kind of give those tools, especially to the vendors, to get that functional. And there are going to be certain developers where they want to program direct to metal that is fully made possible using access to programming languages like C, C++, those kind of Python, those kind of things. And the last two pieces is mostly, I would say, which is kind of working on the hardware portions, which is related to system software and OS and infrastructure, especially the flavors of OS that we support, which is quite broad in nature, starting from Android, which is quite popular in the mobile space, and going all the way to CentOS or QNX or even Zephyr for real-time platforms. And that layer is connected with what we call as a system software, which is system interface and accelerator drivers and those kind of portions. So I would say these are the four important buckets that maps the applications to the hardware. And then packaged around these four buckets is we have access to tools. And the tools here are artificial intelligence model efficiency toolkit, which is what AMIT is called. It helps us from a quantization standpoint. If you happen to have floating point models, how can I really transform this into fixed point models? We also happen to have Model Zoo, wherein you have pre-packaged models that are fully performant. And if you want ecosystem developers to really look at enabling use cases, they can take models from the Model Zoo and get it functional. Neural architecture search, something which is brand new that we kind of mentioned this in the December Tech Summit of last year, wherein we worked with the Google team, the Vertex team, basically, to really make sure that we can compress the models that takes the intrinsics of the hardware to give the highest performance and efficiency. So all this is kind of packaged as part of a tool structure with the expectation that from a development time frame to a deployment time frame, we can squeeze that time, and then we can accelerate scalability and solution deployment across all flavors of developers.
It sounds good. Makes total sense. In addition to the work you've been doing with Google on the search capability, are there other new software components here, or extensions of that software to new platforms that are notable with this announcement?
So basically, if you look at the history of Qualcomm AI, we have been in this space for quite a long time, for approximately 10 years or so. So as such, we have really put a lot more focus on developing, I would say, elements or portions of AI, including around inferencing. And as part of this release cycles, what we're trying to do is we're trying to make sure most of the investments that we have done in different areas, we're trying to package them together with the expectation that we can focus more on performance or performance per watt, energy efficiency, quality of service, latency, those kind of stuff. So that's been a primary push as part of these announcements. And at the same time, as part of these release cycles, we're also giving them access to tools, which was not, available in a different fashion. But now we're trying to map it onto the different structured layers, so it becomes much more easier. So that's what we plan to release as part of these announcements.
Cool. So what do you see as the next horizon? I'm not asking you to pre-announce product here, but what areas are you focused on, like inference server management, perhaps the ML ops side of things? What areas are you focusing on as your next wave here?
I think if you look at from what has already been announced historically, we have a lot of domain-specific SDKs, right? We have the Drive SDK, which is focused on the automotive side, the Intelligent Media SDK, which is focused on mostly on the IoT portions of it, and they have several SDKs which is kind of being built, if not already being serviced out. They've already been constructed based off our AI software stack. And our expectation will continue to develop these, domain-specific SDKs to really scale and function and get them out. So that would be something we'll continue to put a lot more attention. And the second portion of it is, we'll continue to also expand, as you stated before, is how do we really scale the number of operators? Really, can we make sure right out of the box you get both functionality and performance? Historically, it was mostly functionality. Now we're focusing on performance. Can we scale this to different flavors of dual model architectures? Historically, it was very convolution heavy, but can you look at newer models like transformers, generative networks, mixture of experts, those kind of stuff? So that will be kind of a focus of attention, is to really make sure use cases, which was very vision-centric only, can now go on to different modalities, which is like linguistics-based, recommendation engines-based, commerce-based, or even multimodality kind of stuff. So this is, we believe, is a strong foundation to really drive innovation at the edge, because the software happens to be one of the toughest challenges to really, because when the rubber hits the road, you want to make sure that you make it easy for deployment. And I think this first step is really anchoring towards that vision state.
Right. Yeah. It sounds like get the foundation right, then you can build on top of the foundation. As everybody knows, AI chips without software is just melted sand. And if you want to use it for something, you need the right software available, and it's got to be performant. It's got to be easy to use. Yeah. And I think your point about making it the software broadly applicable across the rich set of AI platforms that Qualcomm envisions, and they already have, that's critical for your developer success. So all sounds good. Well, listen, Vinesh, this sounds great. Thank you very much for your time. Good explanations. Look forward to seeing what you guys do next as inference processing becomes really the dominant marketplace for much of the AI in the cloud, from the cloud to the edge. So thanks again for your time, and we'll hope to talk to you again soon.
Sure. Thanks, Carl, for having me, and it was a pleasure talking to you again.
Thank you.
Thank you.